Hey guys, what's up? I'm back with day 2 review here. I just wanted, there were some questions on U substitution on Monday that some people struggled to kind of remember what was going on with that. So I thought I'd do a review just on U substitution. Um, do U substitution differently, whether it's definite or indefinite integrals here. So let's start with indefinite. Okay, so let's say I have the integral of 4x over x squared plus 3 dx. Okay, so there's the antiderivative that we have to do. First thing we should know when we look at this is we don't have any quotient rules for integration, or product rules or chain rules for integration. So when we see a complex looking integral, it's either going to be one that we're supposed to know off the top of our heads, like things like 1 over x squared plus 1, which is arctangent, things like that, or more likely it's going to be a U substitution problem. We know we can do U substitution when we see something that we're going to replace with U, and the derivative of that something looks like what's remaining in the problem. With polynomials, usually the higher power one is going to be our U. In this case, if I let U equal x squared plus 3, the derivative of x squared plus 3 is 2x, which is pretty similar to 4x, something that I can deal with. Okay? I'm going to show you two different ways that you could solve this problem. So here's how I would probably do it if it was me. I would let U equal x squared plus 3. Okay. If U equals x squared plus 3, then I need to do my du. And I'm really doing du dx when I'm multiplying the dx to the end. So I'm going to get 2x dx. What I have up here isn't 2x dx. What I have up here is 4x dx. So what can I multiply the right side by? So it turns from 2x dx to 4x dx. Well, I would multiply both sides by 2. And I'd get 2 du equals 4x dx. I want this to match this up here. Okay. So then rewriting my integral, I put my 2 at the front, I put my du at the back. That's going to take care of the dx and the 4x. And all I have left is x squared plus 3 that's in the denominator there. Well, I'm going to call that denominator, right? I already subbed out. This x squared plus 3 is being replaced with u. What's holding its place on top? Well, it's the number 1. Okay. The reason I did this is now it's a really easy integral to do. The antiderivative of 1 over u is ln absolute value u. For indefinite integrals, we can't leave our answer in terms of u when the question was posed to us in terms of x. So I'm just going to take this and sub it back in for u, and I'll get 2 natural log x squared plus 3. Let's see. In fact, I don't even need absolute values around that x squared plus 3 because x squared plus 3 is always positive. So if you want, you can write it with parentheses instead of absolute value. Okay? Another way you could have done this problem is you could have immediately factored out this 4. Since the 4 is on top, it's going to come out as just as a regular 4. Now again, I'm going to let my u be x squared plus 3. My du then would be 2x dx. What I have in here isn't 2x dx, it's x dx. Well, I'm going to get there through multiplication with 1/2. So I'm going to put both my 4 and my half out front, because my 4 already was out front. The half goes out front here. du at the back. That takes care of x dx, and I'm left with 1 over u. Well, simplifying 4 times a half just gives me 2. And I'm right back to where I was before, with 2 ln absolute value u plus c, for an answer of 2 natural log x squared plus 3 plus c. With definite integrals, what we have to do is we have to adjust our, it's just a little bit more complex with indefinite integrals. Okay. So let's say I have the integral of x over x squared plus 5. And, I should have thought of this a little bit. Let's say we go Well, okay, I'll just pick some numbers. It's not going to work out super nice. That's all right. I'm going to pick, we're going to go from 2 to 3. Sorry, I should have thought out a numbers that would work better. So again, here's what I would do. I see that x squared plus 5's derivative is 2x. So letting u be x squared plus 5 is the right move here. However, just notice that there's a square root around that, which we're going to have to deal with later. So I'm going to have u, I'm going to let u equal x squared plus 5. Du then will be 2x dx. I'm going to fix my 2x dx. I need it to say x dx, so I'm going to multiply by half. I'm going to put my half at the front, so this is the same as half at the front, du at the back. That's going to take care of my x and my dx. I have a 1 holding the place on top, and I have square root of u on the bottom. Okay? Notice that it's not 1 over u like it was in the last problem, it's 1 over square root of u. The other thing we need to do is these two numbers need to change. They need to be in terms of u and not in terms of x. On definite integrals with u substitution, we adjust our limits of integration, and then we don't have to make that step of going back to the x. So when I plug in, I get 2 squared is 4. Right? I'm plugging this in for x to figure out u. 2 squared is 4. 4 plus 5 is 9. 3 squared is 9. 9 plus 5 is 14. Okay. Now I'm going to take one step here to make this easier to do an antiderivative. 1 over root u is the same as 1 over u to the half, which is the same as u to the negative half. Okay? I'm just going to make that adjustment. Now it's just a power rule, bump and divide. Don't forget to keep writing your half. I'm going to bump the power up by 1. Negative half plus 1 is positive half. And then I'm going to divide by half. Dividing by half is the same as multiplying by 2. Okay. Then I'm going to pull this and multiply it with the half to get 1. So now I just have to plug in 14 and plug in 9 and subtract them. Half power means a square root, so my answer is square root of 14 minus the square root of 9, which will leave as square root of 14 minus 3. Okay. So that's how we do u substitution with definite integrals. A couple of things that we should be able to do by hand. if I have to do the integral of e to the 5x dx, right? Let me show you what this looks like with u substitution, and then let's see if we can do it faster. I just want to make this e to the u, right? So I'm going to let u equal 5x, because my du then is simply 5, right? The derivative of 5x is 5, and I get 5 dx. But notice I don't have a 5 dx, I just have dx, so I adjust with a 1/5. So this becomes 1/5 integral du at the back. That takes care of dx, and I'm left with e to the u. E is its own derivative and its own integral. So this becomes 1/5 e to the u plus c, which becomes 1/5 e to the 5x plus c. Okay. Well, what if I had this then? Well, what I want you to be able to do is just say, okay, that's going to be 1/7 e to the 7x plus c. I want you to be able to make that move, okay? The general form here is integral of e to the ax, where a is any constant. That's just simply going to be 1 over a e to the ax plus c. Okay. Similarly, we know that the antiderivative of sine x is negative cosine x, but what if it's sine of 4x? Okay? Well, again, we're going to have that 1 over a come out, right? I'll show you with a u substitution. First, if I let u equal 4x, then du would be 4 dx. I don't have 4 dx, I just have dx. So I'm always making my adjustment with that 1/4. So this becomes 1/4 integral sine u. So that becomes 1/4 negative cos u plus c, which is going to become negative 1/4 cosine of 4x. Well, then if we see this, we should immediately know that this is going to be negative 1/10 cosine of 10x plus c. Again, think about it. It's a way to combat the chain rule, right? If I like cover up this 1/10, right? If I just do the derivative of cosine of 10x, I'm going to get negative sine of 10x times 10. Well, we always get that chain rule times 10 coming out. To combat that when we do an antiderivative, we do 1 over what that is. Okay? So you should know, if you get the integral of cosine of 2x, well, we know that the antiderivative of cos x is sine x plus c, but that 2 is going to call for an adjustment, right? If you can do this quick in your head without the u substitution, it makes it a lot easier. This should be simply 1/2 sine 2x plus c. Okay. That'll be it for today. I will catch you guys tomorrow for With Calculator Wednesday. See you then. 2 chains. Bye.